Now we have discrete distributions. So one of the discrete distribution is, and discrete distribution means finite sample space. Positive, let's say success, failure, winning, losing, number of customers that are going to churn, number of orders. This is known as discrete distribution. And what is discrete distribution? I'm saying the first discrete distribution is binomial distribution, in which we have success and failure. So there are two outcomes. It's like tossing a coin. One is heads, one is tails. Um, let's say playing a game, who is going to win, who is going to lose, whether a customer is going to churn or a customer is not going to churn, whether we are going to pass the exams or we are not going to pass the exam. So whenever we have two outcomes, it's binomial distribution, right? And objective is to find the k successes out of n trials. So let's say we are doing n trials. What is the probability that we'll have k successes, right? So probability of success is p and probability of failure will be 1 minus p, because total probability is always 1. And probability, we say, do not change over the period of time. Is it clear till now?
Yeah, it's clear.
Okay. Now we are saying what is the probability mass function of binomial distribution. This you must have read when you were in your 11th class or 12th class. That's how the function looks. If it is equal to x, ncx p raised power x into 1 minus p raised power n minus x, right? And this is the formula. And then we have mean is given by np and variance is given by np into 1 minus p. These are all formulas. I don't think you have to remember this, but you have to remember the use cases of binomial distribution. Use cases are important, right? Use cases are very much important. Is it clear?
Yes.
Yeah, clear. Clear.
Have you ever tried to implement binomial distribution using Excel formulas? Okay, today we'll do
No,
that. We are
no.
not going to implement, we are not going to put values in the formula. We are going to use this using Excel. We're going to solve problems using Excel. But is binomial distribution clear to everyone?
Yes.
So moving ahead. So this is the one, right? Don't apply formulas. Just tell me whether it's a probability mass function, cumulative distribution function, and what is x. Is it equal to 20? Is it less than equal to 20, greater than 20? All of that. Okay. And what is x equal to?
X will be 20 because it's given 20 customers mentioned clearly. So yes, X will be 20.
Okay. Okay. So what is saying? Saying fashion trends online is an e-commerce company that sells women's apparel. It is observed that about 10% of the customer return the items purchased by them for many reasons. So what is the probability that customer will return an item?
1 by 10.
Pro- 1 by 10?
Yeah.
Yes.
Okay. So here I write probability of returning is equals to 10 by 100, which is 1 by 10, which is 0.1. This is clear,
Yes.
Yes.
right? Now we are saying on a particular day, 20 customer purchase items from this fashion trends online. They are saying probability that exactly 5 customers will return the items. So this is, first of all, is this a probability mass function or cumulative distributive function?
Probability mass function.
Why? Because
Exactly. There is
Because
Exactly 5 is given.
given.
So
so can we write it as p of x equal to 5,
yes.
right? What is the second one? Probability that a maximum of 5 customers will return their items. Is this a mass function or cumulative distributive function? Here I
cumulative.
write p. So can I write this as p of x less than equal to 5? Average number of probability that more than 5 customers will return the items. How I
CDF
write this?
greater than 5. X is greater than 5.
Can I write this 1 minus p of x less than equal to 5?
Correct.
Because it's saying
Yeah, yeah.
more than and we already know 5 or less than 5. Number of customers, implement these formulas, which is np and np into 1 minus p. So fourth one is np and fifth one is np into 1 minus p. Any doubt till now?
Okay. So in the third
This is
question,
so,
yeah, I
are
have a
we
doubt.
clear?
I have doubt
Yes,
in
tell me.
third part.
Tell
So
me.
in third part, we have in the previous example, it's like success, and if we want to count failure, it's 1 minus success. So we have applied this
Yes.
formula in the third part. Or
Yes.
in case we can directly, we can also get the third part answer directly. Means if we are calculating more than
So
greater than
you
5.
can do this P of X greater than equal to 6.
Yeah. So
Since,
yeah.
yes,
means both will give me the correct answer. Correct.
same answer,
Mm.
exactly same,
Yeah.
because the total probability is 1. So what is the probability of failure? It is 0.1, right?
Yes, right.
0.1 was the probability,
Yes.
exactly. Now I'm saying, what was the first one? P, what is the total number of N? It's 20, right? The first one was exactly 5 customers. 5 customers. So my X will be 5, right? So what is the formula? You go to equal to, you write binomial dot distribution, the first one, binomial distribution. What is the number 5? What is the number of trials total, which is 20? What is the probability? 0.1. Now you tell me, is this a probability mass function or cumulative distribution function? Which one is it? Mass function, right? So we'll write
Mass
false.
function.
We'll do this, and this is the answer. The first one answer is 0.031921. Is it clear? How
Since
we
it's
have
mass function, we have inputted false.
false? Yes.
Okay.
If it
Okay.
is a cumulative distribution function, we'll include true, which you will get to know now. So
Okay.
for
Okay. Okay.
example, this less than and equal to, less than equal to, right? Now I'm saying, what is my X? It's again 5. We'll go here, binomial dot dist. Binomial distribution, number is 5, trials is again 20, probability is again 0.1, and this is cumulative distribution function, so true. Remove this, 0.988747. Is it clear? Now third one, what we had, more than 5, right? So I'm saying more than, here we have X, which is again 5. So what we'll do, 1 minus the above one, which is less than or equal to 5. So this is more than 5. What is my average? Fourth one is average. Average, which is NP, which is equal to, what is my N? This is my N. What is my P? This one is my P. So this is the average. And what is variance? NP into 1 minus P. So what it will be? What is my N into P into 1 minus again P,
Oh.
right?
Right.
NP into 1 minus P. 1.8 is the variance. Now let's try to understand this a bit more. So I'm saying that probability of exactly 5 customer is 3%, right? This is the one. Let's see this. See, probability of exactly 5 customer is 3%. How? I'm saying my average customer is 2% and my variance is 1.8. So that's why if you're saying that 5 customers will try to return, it's very, very less. It's very, very less probability that these high customers are going to return. So it's 3%. And if you look at average and variance, it makes sense. Less than equal to 5, 99% chances that less than 5 customers are going to return, and more than 5, only 1% chance.